So in this short video, we will learn that how we can detect 4 core issues of panel data like multicollinearity, heteroskedasticity, autocorrelation, and cross-sectional dependence using STATA. So in this short video, we will learn that how we can detect these issues. And for this purpose, I have used my STATA 18, and here is the tab file. So I will first look for the data. I have imported the data to my STATA. So you can see here risk is my dependent variable, and then governance, sales growth, working capital management, size, these are my independent variables. So if we first we will check multicollinearity. So it's very simple that first we will run the regression command regress and my dependent variable, then list of independent variables. So these are the results of my simple OLS. Then if we have to look for the multicollinearity, the simple command is VIF. So here is the VIF results. Usually VIF value higher than 4 says that there is a moderate multicollinearity, but if it's higher than 10, there is a serious issue of multicollinearity. So other than governance, all of my other variables are like within the range, so there is no serious issue of multicollinearity in my data. Next we will see that how we can run the heteroskedasticity set. So for this purpose, first of all, we have to declare the data set to be our panel data. So here that's command is xt set, and then my id variable, and then my time variable. So I have declared the data set to be a panel data, and then I have to check the heteroskedasticity. First of all, I have to run the fixed effect model. That is simple again. Here I will input my dependent variable, that is risk, and then a list of independent variables, and then fixed effect. Okay, so here's are the results of my fixed effect model. If I have to check the heteroskedasticity, I have to write xt test 3. So here is I have run the modified wall test for group wise heteroskedasticity, and a significant p-value denotes that there is a problem of heteroskedasticity in our data. Now if I have to check the autocorrelation, first I will check the first order autocorrelation. So command is xt serial, and then I have to write my in the same sequence dependent variable, and then the list of independent variables. So I will copy it from my previous command and paste. So here's I have checked what I have done. Actually I have run the Woolridge test to check the autocorrelation. So a significant p-value denotes that there is a problem of first order autocorrelation in my data. Now I will check, there are actually 2 types of autocorrelation. I will check the panel specific autocorrelation. Again the command is same, but xt serial, then I have to write pm because it's port mount test that will check the issue of serial correlation. It could be at lag 2, at lag 3, so we call it as panel specific autocorrelation. So p-value is insignificant, so the interpretation is that there is no problem of panel specific autocorrelation, but there is a problem of we can say first order autocorrelation in our data. Lastly, I will check that how we can run the check the cross-sectional dependence. Again, first I have to run the fixed effect model, and for cross-sectional, of course, if I have large t and small n, the command is different, and if I have large n and small t, the command is different. In my case, we can see that I have 20 years of data, and this data is for 19 firms. In this case, if 20 years data for 19 firms, it means that my t is actually smaller than n. So when t is smaller than n, then I have to run the command xt CSD. Sorry, if larger t, I have large t and small n, then I have to run the command xt test 2. So again, significant p-value, it means there is a problem of cross-sectional dependence in our data. And if just assume that if my the structure of my data is that I have large t, I have small t and large n, then there would be a different story. Then I have to run the command, we call it xtcsd, pisa run test. So again it is significant, but this test is not suitable for the structure of my data, but we can run this test as well. Thank you very much.